Well, hello, everybody. Good morning, good afternoon, good evening, good night, good year, I suppose we can say, to everyone, wherever you may be across our lovely world. Thanks for joining us live yet again for Serverless Office Hours. We are streaming on the AWS Switch channel and also on the YouTube AWS Events channel. It is 2026. Who would have thought about that? Yeah, well, we've got some experts. We're going to be talking about APIs today as well. Srijan, welcome to Serverless Office Hours. First-time person, product manager for API Gateway. What is your journey? How do you get to be a product manager for API Gateway at AWS? Sounds like a cool
Yeah,
thing.
I started. Yeah, it definitely is. I joined AWS about 4 years ago, and since then I've been on the Amazon API Gateway Service team, looking after a lot of the features and launches that we've done recently. So yeah, very excited to be here and talk to you folks.
Cool, excellent. And welcoming back our two other guests. Giedrius, welcome back to Serverless Office Hours. You have a nice background behind you. Looks, sort of wintry, but sunny. Welcome back. For people who don't know the amazing Giedrius, what do you do, Giedrius?
Hey, I'm specialist solutions architect. I focus on the next generation developer experience, integration services, and I also lead our internal technical community API focus area. So I spend a lot of time with customers and service team, and I'm in between them. And that's what I do most of the time.
Cool, excellent. And yeah, Giedrius is just basically our API guru internally. So everything that anybody needs to know about API Gateway, Giedrius is the person we all turn to. So we're glad to have him on the stream. And last but of course not least is probably our most frequent guest, Anton, because Anton basically knows everything about everything. So welcome back, Anton. How are you?
Oh man, you're overselling me. I'm doing good, doing good. Happy New Year, everyone. I'm still Anton, still based in Austin, Texas. So I'm just like Giedrius, I'm a solution architect for serverless. I cover a little bit different area. I work primarily with SaaS customers, right? And I help them to implement various multi-tenant platforms, SaaS platforms, cloud applications. And you can obviously add at scale to everything we do here.
Excellent. So AWS reInvent was at the end of November, beginning of December last year, and obviously huge amounts of announcements. I'm actually working on a blog post at the moment, which will go through 3 months of serverless at AWS, and that sort of feels like 3 years towards the end of the year because so much stuff is coming out. Obviously, there were loads of big serverless announcements from Lambda durable functions to Lambda managed instances to lots of other things from step functions, test APIs to cool Bedrock things that were going on. I'm trying to think what else off the top of my head. Loads of kind of things. Yeah, the blog post will be out shortly. But obviously, API Gateway is key to anything. And I always say one of the first fundamental things about AWS and even Amazon is all those decades ago when Jeff Bezos said, the only way that Amazon is actually going to be competitive and work is nothing needs to be a direct service integration. It all needs to be behind an API, which sort of means needs often to be behind API Gateway. So Srijan, today we're going to be talking about API Gateway response streaming, but there've been a whole bunch of sort of package of API Gateway announcements that have come out recently. Do you want to sort of get us up to date with what's been going on?
Absolutely, would love to do that. I mean, there have been so many launches this year. We've been very excited about all the launches that we have made, and we've seen some really good adoption. So we started the year with routing rules that actually allows you to do routing not only on the basis of path parameters, but also headers or a combination of both. So which is acts like a director and directs your traffic to the proper API end stage. We then also worked on response streaming. We're going to talk more about response streaming today. In addition to that, we launched enhanced TLS ciphers and versions, which allows you to pick whatever TLS version and cipher you would predefined set of versions and ciphers that we have launched, security policies, and you can apply that to your traffic and restrict traffic from TLS 1.0 endpoints and TLS 1.2 and so on and so forth. We also announced PQ support, which is fantastic. The other big thing that we did was the developer portal. So we know that we have a very good runtime at place. We have forayed into the API management space now with the developer portal, which enables the discovery and documentation of APIs. We did the private integration with ALB, so customers no longer need to use an NLB in between as a hop. Improves latency, reduces complexity of customers' architectures. So that was a big win. And finally, we also announced MCP proxy support. So AI agents trying to communicate with backends wherever they are can leverage API gateway can sit as a bridge in between and translate MCP traffic into HTTP, make the call to the backend and get the traffic back to the AI agent. So has been a brilliant year for us so far.
Cool, excellent. And yeah, just on that last API gateway proxy, that's also with connected with Bedrock AgentCore, correct? Is that they work actually
that is right.
nicely together?
Yes.
Excellent, excellent. Well, excellent. Now, obviously, remember, we are live here on Serverless Office Hours, so please let us know where you're from. Tell us what you did over the new year. Some people saying, "Oh, we took the time off and did some mad coding challenges and learned lots of things." Other people completely took a break. I did a bit of both, mostly actually taking a break a whole week without even my personal laptop turning on. So yeah, let us know where you're from. Edits, who's a long-time viewer, welcome back via Twitch. I'm glad to see New Year as well. And we also have Twincy N, Happy New Year to you as well. So yeah, we love our serverless community. So it's absolutely great to hear from where you're from. But yeah, API gateway. So API gateway response streaming, what is the problem that needs to be solved with this?
Yeah, I can go into a little bit of the details. So previously, API gateway used to buffer the entire response before it was transmitted back to the client, and that resulted in a larger perceived time frame, right? I mean, the latency seemed a lot longer. With response streaming, what we have done is the client can start receiving the response as soon as the response is getting generated. So it's quite instantaneous. Your customers will feel it as well. There is no lag. There is the time to first byte is really low. That's one of the primary benefits of it. So that's the comparison. That's what has changed, and that is how we have evolved from just buffered responses to also having streaming responses.
Okay, so yeah, you did mention buffered responses before, but I mean, before this launch, how do people sort of generally handle long or progressive responses?
Yeah, the long and progressive responses. So we had a timeout of about 29 seconds. So customers who wanted to transmit a large amount of response payloads used pre-signed URLs as a mechanism. They reached out to us for limit increase requests to get the timeout increased from the 29-second default to a larger number. That was a long process. It created a lot of friction. We pretty much recommend all our customers use response streaming unless they are trying to use something like response content encoding or response transformation or caching. So if you're not using those features, we would say that you should use response streaming because it is so much more efficient. The experience is so much more better. And there is a very, very high timeout limit, which is about 15 minutes. So you don't have to file a ticket with us. You can just set the timeout yourself to 15 minutes and start streaming.
Yeah, I mean, if you think about the previous world pre-response streaming, right? If you think about the problems, right? Well, we had like Srijan mentioned that 29-second timeout and 10 megabyte payload size limit, right? But what if you want more? What if you want to send 11 megabytes, right? Or 50 megabytes or more than that? And what if you want your API to not to time out after 29 seconds, right? What if you want that HTTP connection to be up and running for several minutes, but on the client side, you don't want to wait for those several minutes to finally get your response. You want to get that response progressively, right? As it's being generated on the server side, right? So response streaming kind of addresses all of that, right? It helps you with timeouts. It helps you with getting, reducing time to first byte and gradually getting the data. You don't have to wait for everything, for the backend to be fully finished, right? And you can also send more data, right? You're not limited to 10 megabytes anymore.
And for even longer,
yeah, I mean, I actually I wrote a blog post for Lambda URLs, when Lambda URLs had response streaming, and I remember seeing the first kind of iteration of that. So if people have been using Lambda function URLs, and they are many kind of little APIs, the auth isn't as robust and everything, how should people then think about what API gateway response streaming brings to the party above Lambda function URLs with its streaming?
So with that, with the streaming through API gateway, you get all the API gateway API management experience. One thing is you have more authentication authorization options. You have web application firewall integration. You can use private endpoints together with streaming. So in short, all API gateway features are available to you as compared to Lambda function URLs, which are much more limited when it comes to API management feature set. So you get all that rich experience.
Cool. Yeah, I mean, I think that's a great use case. I'm just going to bring up onto. Is this going to work? Yeah, excellent. So this is actually there's a blog post which our experts have written, which I'll link to in the chat as well. And basically, if you want to see what response streaming looks like, this is what it looks like, and that's a pretty simplistic view to show how it's on the left hand side, it's waiting for a whole chunk and then sending it over. And actually, because when I'm in. I was doing the Lambda function URLs response streaming, which was node only as well, and it was cool to learn some of the sort of technical nuance of what actually goes on behind the hood. And this also means why there are some payload limits for API gateway, and why there were some timing limits for any kind of service that does this, whatever it is. And it's basically because this stuff needs to be stored into memory. So you can imagine if you do something from a Lambda function and it's going via the API. Previously, if you weren't using streaming, API gateway would have to basically cache or store whatever the response from the Lambda function until it gets everything from the Lambda function, and then send it onto your client. And obviously, with millions and trillions of invokes going on, that's obviously a capability limit or a capacity limit of the amount of memory that needs to be managed. Well, if you're using streaming, it's basically just going to send it as a pipe through the service, and so actually it's going to use far less memory. And so that's why you are able to do larger payloads and things like that as well, because it's not having to store it in memory. It's acting more as a pass through, and obviously he has to use the the language features to be able to handle that streaming. And so yeah, that sort of made sense into my head of you can't do response stream by normal. With normal kind of things, there's an architectural change that needs to happen for the good. But yeah, it was just an interesting way that something I learned internally about what the buffer and the response streaming is. Anton was cool. He told us some of the use cases as well. Yeah, Giedrius, I did cut you off, and then you did jump back. So hopefully covered what you were going to cover. Was there anything else you wanted to cover in general, or because I want to find out sort of we can see it on the screen. How do we then start using this capability?
Yeah, I apologize for Wi-Fi quality here. So I got cut off. No, I think you covered that experience improvement. That's the first and most important thing in most of the applications that customers are looking for, because nobody likes looking at that spinning wheel on your screen while you're waiting for a response and then waiting for half a minute or so. Everyone wants to start reading immediately, and then we kind of got to the point where most of the chatbot interfaces or even general interfaces are providing this additive kind of experience where you incrementally get information and you just read through it instead of waiting for long periods of time.
Yeah, if you read the blog that I think we shared a link a few minutes ago, right? If you read the blog, there's a quote there from one of the customers we worked with, Salesforce, probably heard the name. Right, and they've managed to reduce the blocking time, the total blocking time metric, by 98%. 98. Right, this is crazy, right? Essentially, instead of waiting, you're starting to get your data. So,
yeah, pretty powerful.
And I suppose in the days of LLMs, when people may have not seen or thought or understood about what streaming looks like, now when anybody's used any chatbot or used any AI kind of thing. You're just used to what streaming looks like, and so the expectation is there.
Yeah, we have seen customers who have used WebSockets in the past for such things. Yeah, I was just saying that we've seen customers use WebSockets for such things in the past, and I think this provides a much better experience compared to WebSockets.
Okay. Well, then I suppose to flip the question around, when would WebSockets be a good solution still to use? Because I know things like we've got a number of different managed WebSockets services where you can use WebSockets obviously with API Gateway as well, along with AppSync events and everything. So for people who are thinking, oh, how should I differentiate from an architectural point of view for response streaming versus WebSockets? How would people think about that?
Well, WebSockets is a great protocol for bi-directional communication, where you want to send data both directions, right, at any point in time. Response streaming is a little bit different, right? You still send a request, right, and then we start streaming the response back, right? So if you need a response to be streamed over a period of time, that's definitely response streaming. If you're looking for a consistent communication channel between client and server without reestablishing that connection over and over again, and data will flow both ways, that's WebSockets.
Also, I would add that if you need even more than 15 minutes, you should look at WebSockets, because WebSockets default timeout is 2 hours. So if you need that channel, that bidirectional communication channel to be open for longer periods of time, that's one more scenario. Also, some of the system integrations require WebSockets implementation. Let's say, for example, if you're working on electric vehicle charging infrastructure implementation, industry standards require WebSocket-based implementation for that. You are not going to be able to switch to response streaming.
Cool, excellent. So we're obviously talking about API Gateway as a serverless service. So obviously there are serverless ways of implementing this, but it's not just actually for serverless services. In fact, it's a whole bunch of services. So what kind of backend integrations does API Gateway response streaming support today?
So right now, streaming supports Lambda integration, so Lambda proxy integration, and Lambda supports streaming as a simple switch in your code, and then in a few minutes we can just take a look at that code. And also blog post that we already shared with you have a link to the GitHub repository with the code samples, along with the samples in the blog post itself. So you just update Lambda handler to start streaming, and that's pretty much all you need to do to start streaming on the backend implementation side. Or it can be any web application that supports streaming protocol. On API Gateway, it's as simple as switching a mode from buffered to streaming, and any client that supports streaming responses out of the box will work just fine. So it's really straightforward, and from developer perspective, really straightforward experience how to enable it, how to implement it. You can use libraries like FastAPI if you are working with Python, and just right there, or in Node.js, JavaScript SDK gives you those wrappers to enable streaming out of the box. So from developer perspective, it's really straightforward experience.
Yeah, I actually want to emphasize this, right? Because the way streaming is implemented, right, it's 100% standard, right? So it's not like you need a special client that supports streaming. I don't want to make a bold statement like 100%, bulletproof or anything like that, right? But it's plain HTTP. It's the HTTP standard way of returning junk using any modern HTTP client, like curl, for example, or whatever HTTP clients you might be using in your applications, right? It would work. It would just work. We've tested a bunch of them, and it just works the moment you enable streaming. And on the server side, like Giedrius mentioned, it can be Lambda with proxy integration, but it can be also a bunch of other HTTP backends also in proxy mode. So if you have applications running Fargate, ECS, EKS outside of AWS, right? If they support response streaming, now you can enjoy that response streaming through API gateway as well, right? Previously, we were buffering these responses. Now you would actually see the data stream through API gateway.
Yeah, another
So
cool
from
thing
them,
is because we also launched private integrations with ALB. It works on private integrations as well. So if you have a custom LLM on your EKS cluster, which can be a Mistral or something else that you have, you can stream responses back using that private integration with ALB and API gateway response streaming. So private integration also works pretty well with response streaming.
oh, cool. Yeah. No, you don't think of the different protocol layer of the ALB, that the data is just flowing through that at a sort of TCP level. And so, yeah, that just works nicely together. I like it. From a Lambda developer's experience, what sort of changes? The two things I'm thinking of, is there anything different with Lambda function URLs if people want to take advantage of the full API gateway? And then also, Lambda Web Adapter, I suppose, is super useful for this as well. So how do things work with Lambda?
Okay, let me quickly take that one. So with Lambda, it's no different. If you had code for Lambda function URLs where you implemented streaming, basically just disable that function URL and use that Lambda function as a target. Only thing, instead of invoke, you will use invoke with streaming endpoint, and that's only change that you need to make if you already have Lambda function URL implementation that has streaming. If you do not have, let's say, if you have just any other Lambda implementation where you request data from some data source and return data, if you get that data in chunks, if you get that data incrementally, or if you generate some data in smaller amounts and then want to start streaming return to the user to that data set immediately as it becomes available, and then just keep adding, in that case, one change in your code that you will need to make, instead of waiting for that entire data set to accumulate in Lambda function and then returning as a response, you will switch to streaming your data as part of your Lambda implementation. So only change into Lambda handler would be, instead of waiting and returning entire response at once, you will switch to streaming. And I think we can simply look at the code and see how it works.
Let me bring it up. Let's see how this all works.
Okay, so in my account, I have 3 different APIs deployed. One is streaming with Lambda that is written in Node.js and uses Amazon Bedrock in the backend. And that's first example. Another example is using Python and Fast API framework along with Strands agents, and it is deployed on Amazon ECS. It's using Bedrock for LLM hosting, but it uses Strands agents for everything else. And last one is same code or very similar code that is deployed to the Lambda function. So both ECS and Lambda, to show how straightforward it is from developer perspective. So first example, that Bedrock client, where I'm using Boto Bedrock client and sending requests to the Bedrock, receiving chunks of chunked data as a response, and simply writing to response stream that is provided by Lambda SDK. As simple as that. There's nothing else that I need to do. Now, because Bedrock client has maybe slightly more hand-holding in the code, that the code looks more complicated. If we look at a similar implementation where you use Strands agents, different version, it's much simpler because a lot of that hand-holding is taken care of. All the scaffolding code is taken care of by Strands agents, and it is as simple as sending request, waiting for payload, and returning streaming response back using streamer. And streamer just takes data and returns back as a response. So you see that in about 30 lines of code of that handler implementation, you can have in the Python code, you can have fully streaming from your LLM application that is deployed on Lambda in this case, or I also have cluster running with the same code on ECS Fargate in a container, serverless container, where the same code runs. And here's a repository, our sample repository that is linked in the blog post. You see that this same code, exactly same code, is used in that container as well as in Lambda code. So you do not have to make any changes to your code when you use it in Lambda or in container if you use Python and Fast API. Now, one caveat that for Python streaming, you would use project use layer called Lambda Web Adapter that adds additional layer and enables your Python code or any other code for that matter that supports HTTP request response to be exposed as a Lambda function. So you can take the same code in Python, deploy it to Lambda, and add that layer, or you can use the same code directly in a container in ECS. And now to show how it works, let me just quickly switch to curl. Okay.
While you're switching over there and that's reconnecting, can I just ask, because Node.js Lambda response streaming is native as part of the runtime, but for Python and things like that with the Lambda Web Adapter, that is technically using a custom runtime for streaming underneath the hood. Is that correct?
It is using Python runtime. It is not using custom runtime. It's still using Lambda runtime, but it adds layer on top of it called Lambda Web Adapter. So
and that handles the streaming.
Yeah, you do not have to deal with maintaining your own custom runtime environment. You still use Python runtime environment provided by Lambda service. But as Python runtime environment natively does not support streaming, only Node.js runtime supports it, you have to use Lambda Web Adapter.
Cool, thank you.
Okay. And now let me quickly grab sample link. So first it is a response coming from Bedrock. So that's first one. You see Bedrock streaming ID of the API, and I'm simply asking explain quantum computing in simple terms. And it starts streaming immediately, word by word or sentence by sentence. As simple as that. And as you see, it responds really fast. So time to first byte would be in maybe seconds. Maybe less than that. Really will depend on factors as in any other request. How many network hops will be there? If you have something running on, let's say, EKS or ECS in your, and then you use private integration target in that case, maybe there are some additional network inspection layers in between that would add some latency, but none of them would be significant. So you get that response streamed almost immediately. Okay, so if I try it again, you see it's really more about network latency in between my laptop and Amazon endpoint in this region, though it's in the same state where I'm in California, but it's not affected that much about anything else. Now, similarly, if I try Lambda, if I try ECS version, so I take ECS version of the same service implementation. You see API ID that starts with 697, and here is link that starts with 697. I ask the same question. Again, it starts almost immediately. This is Python function. So it includes that Lambda web adapter layer, but it doesn't add any latency, any significant or noticeable latency or cold start for deployments on ECS. Sorry, that's let me roll back. This is ECS deployment, so it doesn't have any cold starts. Now, one interesting detail, if we go with Lambda and Lambda web adapter, you'll see that it last example with API endpoint that starts with I0. And I'm asking the same question. Now you see this cold start first time when it starts, when it's deployed for maybe a second or two. And then on the next invocation, it starts immediately the same way as ECS, so no any additional notable delay there.
Excellent. So yeah, that is a simple demo, because it's basically the same code running in 3 different places,
Exactly.
which gives you the flexibility and streams the same kind of thing. Hopefully we're going to learn a bit about quantum computing, because that would be interesting as well. We've never done a quantum computing serverless office hours. That's going to be an interesting one. Excellent. Well, thanks for putting the demos together. So I just want to, Killswitch does ask 777, so is this cold start good or not?
So yeah, so in case of that Python and Lambda web adapter, as additional layers added, so Lambda initial start is a bit slower for the cold start. No, it's not a good user experience if you have use cases, or if you have this usage scenarios where there are long periods of inactivity between invocations. In that case, you would see those cold starts. Otherwise, if you have steady loads or near steady loads, when new Lambda execution environments are not being brought into picture, it not being created, you will not see those cold starts at all. And also, there are other ways to address cold starts. If you want to use Lambda and web adapter, in that case, maybe provision concurrency would be something to take a look at. If you need exactly those, eliminate those cold starts entirely, that's one of the options. Another option, again, depending on your implementation, could be snap starts. Lambda function allows that to eliminate cold starts or address them as much as possible, or simply use more lightweight implementation, as you did see Node.js without web adapter, where streaming is part of the SDK directly, doesn't have that significant cold start.
Yeah. It's important to understand the reason for cold starts.
Yeah, no,
right?
that's interesting. Oh, carry on, Anton.
Yeah. Is it a good or bad thing? Kind of both, right? So the reason we have cold starts is because Lambda is it's a peculiar type of compute, right? The reason you do not have cold starts with ECS is because those containers are running 24/7, right? Pretty much just like any other type of compute, you have your workload running 24/7, and you're paying for it whether you use it or not. Whether you're using it for 10% capacity of the CPU or 90% capacity of CPU, you're paying for it. Lambda is different, right? Lambda bills you only for what you actually use. So if your code runs for 3 times each time for half a second per day, this is exactly what you're going to be billed for, right? But in order to be able to do so, after some period of inactivity, right, we're shutting down those execution environments, right? Because we don't want to bill you for something you're not actually using, right? We're not billing you for idle execution environments, only for when your code is actually literally being executed, right? So after a period of inactivity, we deactivate, shut down those execution environments. And once you invoke your function again, we create those execution environments from scratch, right? So that's essentially the idea of cold starts, right? Like you just mentioned, if your workload has a consistent traffic flowing in, you're probably not going to notice cold starts, right? What we're seeing is that in real production applications, cold starts constitute less than 1% of all the incoming requests. So your P99 will not be affected by cold starts, right? But if you have a function that you invoke like 3 times a day with significant periods of inactivity in between, yep, you will see cold starts. They're not, a major problem, right? They're just, a property of the serverless compute option where you're always only paying for what you actually using, right? That's the reason you have cold starts, right? It's a trade-off. It's a balance, right? If you absolutely do not want to have cold starts, we have solutions for that. You can use provision concurrency. We just announced Lambda managed instances or so on. So I hope this is helpful.
Yeah, no, thanks, Anton. Yeah, and just to reiterate, from 2 different things, there's a huge amount of content out there with loads of solutions for cold starts. Some of it's stuff that you can do in your own code. All of us have done reInvent talks on this, other videos and everything. I don't want to say cold starts is not a problem, because it certainly can impact you, but it's way less of an issue if you haven't been paying attention for a few years, because there are just so many ways. There are native runtime optimizations that happen, code things you can do, or you can use managed service things like provision concurrency, snapstart, and all that kind of thing. And the other kind of thing is, if you implementing response streaming, well, before you had a cold start anyway while you were sending all this traffic anyway. So ultimately, if it took 5 seconds to send your previous response from an LLM or that kind of thing, you're waiting for 5 seconds and then you got your response anyway. Now you're waiting, maybe you're waiting for a second for a cold start, maximum maybe, but your initial data is coming through in 1 second, and then it's going to catch up with 5 seconds. So as Anton says, it's all about trade-offs and things like that. So 2 different things I want to say is kill switch 777. What if I create an event rule that keeps the Lambda warm and hits it every 2 minutes? How much extra cost can it add? I think I'll say clearly that this is a bit of an anti-pattern because it's not deterministic. Sure, you can create a rule that is going to cold start your Lambda function and that's going to be warm, but you don't necessarily know it's going to be the same execution environment. And that's just going to be, the additional cost is, who knows, depends how many Lambda functions, how much it's going to run, probably not a lot of money. If you do need something, use provision concurrency when you're going to put it up or down, or often just, offer the cold starts, not the bad kind of thing. You think about it. As Anton said as well, when this ramps up for production applications, cold starts is less than 1%. This isn't what AWS is telling you. This is huge amounts of external people who look at their own metrics and look at their own code and do that. And so as a developer, you freak out because you do a new deploy, basically re-provision your Lambda functions, you get a cold start. You redeploy your provision a Lambda function, you get a cold start. And you think, oh my word, every time anyone hits this Lambda function, they're going to get a cold start. The more traffic you have, the less cold starts you have as well. And in fact, Ran the Builder, who is one of the world's experts, Ran Eisenberg, hello, welcome, thanks for doing. You can implement dynamic provision concurrency mechanism, or actually fix the cold starts and optimize. So yeah, that is the one as well. There was I don't know if this was quite related to cold starts with a workaround. I find the first Lambda call initiated after 24 hours always fails. Then the rest are fine. I'm not quite sure what's happening, but often there can be things inside your code that is making a database connection or to something external, and often that is the thing that is failing. And then it's not the Lambda function that is failing; it's some call that is happening. And so you do need to think about what you're calling in your code. Call something in the initialization phase in the cold start, and then check that database connection is there in the handler. If it's not, recreate it in the handler as well. So again. Lots of different options. Please look online for cold start tips and tricks. There's plenty of stuff out there as well. It happens with Lex, simple invocations. Toe44, interesting. Because that would be just a straight SDK call. There's not a database connection with Lex. Interesting. Anyone got any bright ideas for Lex? I can't think of anything offhand, but you've got something to think about.
I don't know from the top of my head.
Yeah. Excellent. So just before we do go on to some of the other kind of things, there were some questions which were earlier on. Before a question, the sample repository, I did put this in the chat, so this has all the code as well. There was something, an early one. Cloud Architecture asked really early on. So there's no longer a 20-second response limit when we were talking about limits. So Srijan, yeah, I think you mentioned 15 minutes. Is that to link up with the Lambda timeout? Is it different? Can it be any longer, any shorter? Anything else other people should think about in terms of response limits?
For now, it's not configurable. It's going to be 15 minutes, so you can configure it just that's the same way you used to configure the timeout for buffered. But now you can go up to 15 minutes, and there is no restriction around 29 seconds.
And I want to add that for buffered response, 29 seconds is not a hard limit, it's initial limit. You can increase that limit to 5 minutes if your workload requires that.
Yep.
Cool, yeah.
Yep.
Thanks, Giedrius.
So it's a very important distinction, right? The streaming mode does not replace the buffer mode. It's a separate mode, right? So the buffer mode remains as is. 29 default, can go up to 5 minutes. In streaming mode, you can go up to 15 minutes of end-to-end timeout, but you do have idle timeouts to consider, right? So if you're thinking I'm gonna send a small chunk right away and the next chunk 15 minutes later, that's not gonna work, right? If you're not using that connection, we're not gonna keep it idle for 15 minutes. So we do ask you to send some sort of a keep alive once in a while, right? Now, if you're using edge optimized endpoint, that's gonna be, the idle timeout is 30 seconds. If you use regional or private, that's 5 minutes, right? So give us something at least once in 5 minutes so we would know that connection is still alive, right? We do not want to maintain that connection to your backend if it's no longer actually being actively used, right? That puts load on your backends as well.
Cool, thanks. And is there a data size limit or something? I mean, how much? I mean, 15 minutes is a long time. You could push a lot of data over that. Is there any limits or quotas or considerations people should think of that?
Yeah, so there is no data size limit per se. However, right, we do not restrict the bandwidth for the first 10 megabytes, just like we never did it before, right? For the remaining data, we do restrict bandwidth to 2 megabytes per second. Okay, so as much data as you can squeeze within that kind of boundary, go ahead, do, right? The reason is, it's an API gateway. It's not a replacement for S3, right? If you have huge, gigabyte files that you need to return to your clients, probably API gateway is not the most optimal way of doing that, right? But if you do have a scenario where you need to stream data, larger chunks of data, now you can do it with response streaming, right? So don't confuse API gateways with object storage.
And keep in mind that depending on your backend integration target, you may have slightly different bandwidth caps. For example, Lambda will give you up to 6 megabytes uncapped bandwidth, and then will cap to 2 megabytes per second. In case of HTTP proxy integration with API gateway by itself gives you 10 megabytes uncapped bandwidth. So if you see that your bandwidth is limited much sooner than you expected, take a look at your integration target and what caps are there.
Cool, excellent. And yeah, Srijan, the last bit, AJ Potato 214, that's a nice name. Does streaming change the pricing model?
It doesn't change the pricing model per se. We haven't really introduced a new dimension on which we are metering. So we are still charging for the number of requests. The only difference being because we are allowing you to go beyond 10 megabytes. So every 10 megabyte chunk is treated as one request. So for example, if you have a response coming back, which is about 9 megabytes, then you are charged for one request. If you have a response coming back at 65 megabytes, that'll be 7 requests instead of 1. So you just be charged for 7 requests and not just 1 request. That's the only. That's how we have simplified the pricing for this feature.
Cool, thanks. Yeah, and another question we had via YouTube, Daye Brayon, apologies for my pronunciation. Is there a recommendation to integrate the response streaming pattern with AgentCore? Great content, by the way. Yeah, thank you to everyone who's done the content. So yeah, we did speak about AgentCore earlier when we were talking about the managed MCP gateway connected to the AgentCore gate. I think it was a runtime. No, well, part of the AgentCore, but yeah, how does the response streaming for API gateway work with the AgentCore. Now, I presume that's the runtime you're asking directly for the runtime, or is it also via the AgentCore gateway? So I presume the runtime. So let's go with that.
I can take it. So basically, you configure the target of your AgentCore gateway to be an API gateway endpoint, and using that, and then it is all on API gateway. So if your API gateway is configured to stream responses back to the client, it will just start streaming responses back. So the integration there is very seamless. So you just point your AgentCore gateway to the specific API endpoint that you want to integrate with, and just configure the API endpoint to stream responses back. So it's quite simple that way.
Yeah, exactly. Because AgentCore, runtime, and gateway, they already support streaming, right? So you can think of them as HTTP backends that support streaming. So point API gateway at those backends, and you'll get integration with API gateway. I'm at this point, I mean, this all needs brand new. We just launched it like before reInvent. I'm not familiar with a specific sample that implements it, but I've made a note to myself to see whether is anyone already working on a sample code on serverless land, or do we need to create a new one?
Yeah, I need to think for serverless land patterns. I'm sure I've seen somebody doing something, but I need to check whether we've merged that or what's been working on. The mists of time across Christmas and New Year have fogged my serverless land pattern.
But to emphasize this again, if you have an endpoint, HTTP endpoint that supports streaming, be it on AWS private or outside of AWS public, you can hook it into API gateway response streaming. It would work.
Okay. And then I suppose just the inverse of the question, that obviously lots of AI use cases, because we're all used to seeing how AI does streaming, but what are the sort of non-AI use cases where this can be useful? And I know larger payloads we've covered. What other things, so we can just get a full list of the use cases that this could be useful?
So I can give you a few that I worked on, right? And I fully acknowledge that 5 minutes ago I said it's not a replacement for S3 like object storage, right? I did work with a few customers that actually wanted to return binary files, right? It was PDFs, right? Those files were not huge, right? They were, I don't know, maybe like 20, 25 megabytes in size, right? And they were extremely happy to hear that now they can. Web pages, right? Time-to-first-byte means improvement in user experience. Yes, your LLM responses is one thing, one way to improve the user experience. But if you're building a website with a lot of HTML and you do not want your end user to actually wait for the whole thing to be rendered on the backend, right? If you have using like a micro front end pattern, right, that's like pure gold, right? You can have significantly more responsive web applications, right, where things are happening dynamically without, that spinner like Giedrius mentioned, right? That's another use case I can think of, right? Timeouts, right? Sometimes you do need just a longer timeout, right? So now it's much easier to get it. Progress bars, right? This is so simple, but that's what I like about it, right? So sometimes you make a request to get some data, right? And it takes time to get the data. And during that time, you don't want to guess whether it's going to take like 3 minutes or 7 minutes. You want to have some sort of progress indicator. Well, now you can, right? You can use response streaming to actually send chunks of progress indication, right? And again, previously also common to do something like that with WebSockets, but now you don't have to. You can use the same HTTP protocol to send the data back from your backend to the client. So these are some use cases that I've seen in my experience, right? I'm guessing there are probably a bunch of others as well.
Yeah, one obvious one that you would see used, that response streaming used as underlying implementation would be server sent events. So SSE's implementation through response streaming, though you will have to keep that connection open, that response streaming and sending those keep alive messages that Anton mentioned to make sure that your session do not time out. One more side note to keep in mind, that CloudFront supports streaming pass-through as well. So if you want to put CloudFront distribution in front of API gateway with streaming enabled, with streaming responses, you can do that as well. So that opens additional set of use cases that you can use API gateway response streaming for.
Interesting. Yeah, I will get onto a question for that as well. But yeah, just H Damien 111080. Thanks for joining us via Twitch. IoT data. I suppose that is a use case, although I think IoT data is often the other way around, where it's sending it from the sensor. This is response streaming, not taking data out of AWS rather than into AWS. But I suppose you could use IoT in some sort of use case as well. I mean, ultimately, it's just data.
Yeah, usually IoT is from the device to the server, right? But
yeah, exactly.
If you have a use case where you need to stream IoT data from the server to IoT devices, sure, why not, right? Again, keep in mind, it's one way, right? Request and then stream response. Because I've seen WebSockets used a lot for IoT scenarios, right? But if you have a use case to use response streaming, why not? It's just HTTP.
Cool. So actually, just as Giedrius mentioned, some of the other functionality of an API gateway. I mean, the reason people use API gateway is, authorization, throttling, WAF, logging, all those kind of things. Anything people need to think about for response streaming for that as well?
So, I mean, in a nutshell, vast majority of the functionality you're familiar with from API gateway will continue to work. Right, like security, TLS, audit, all those request throttling, etc. Right, things which are not compatible with response streaming. So, for example, modifying responses. Right, in buffered mode, we have this capability, right, response transformers, where you can actually have a piece of ETL, right, basically saying, my response was returned as JSON. I want to convert it to a different JSON schema or to a different textual format. API gateway allowed you to modify responses. So this was possible because we were buffering those textual responses, right? And then once we have the whole thing, we can manipulate it, right? We can do transformations. With response streaming, you cannot do that because we have no idea, what the whole response is. We're streaming that response as we receive it, right? In order to reduce latency. So that's one thing that comes to mind to be aware of, right?
Yeah, another one to keep in mind that you cannot enable payload compression when you use response streaming. Yeah, if you absolutely need to compress that response stream, you will have to implement it in your backend and also to make sure that your client supports it. And some of the compression algorithms are optimized for streaming responses. So take a look which of them will work best for you. But neither API gateway nor CloudFront supports response streaming when response streaming compression when it comes pass through.
And it hit me the moment you said compression, response caching, right? Since responses are streamed back, right, we cannot cache them, right? So yes, response caching is not going to work as well with stream mode, right? Because it's a data stream.
Correct.
Okay, and Simone, yes, thanks for joining us via Twitch. Did you talk about how this affected distributed tracing already? No, and so your follow-on comment was, when do you insert the distributed tracing headers? I think that'll be the beginning, but I'm just guessing here.
So headers are part of the initial metadata. If you look at the blog post, response streaming starts with the metadata section that includes content type, includes headers and cookies as optional fields. So that's where your tracing headers or any other headers for that matter would be returned. So at the beginning of the response stream.
Yep.
Cool. Yeah, that makes sense. I'm just checking what I had a list on. Just some starting points. We've got a few minutes left. Someone wants to get started. Obviously, you could build a whole ECS cluster or EKS cluster and do some streaming. But what's a simple mode for people to sort of get their feet wet with some API gateway response streaming?
check out the blog. I mean, you'll be surprised how simple it is, right? It's literally very simple. Like you flip a switch, you change the mode from buffer to streamed, and it works, right? So we do expect your backend to support streaming as well, because if your backend returns the response as one chunk, obviously, we'll just stream the whole chunk. So technically, it's still a streaming, but there is no user experience improvement, right? So we will just get the stream from your backend and streaming back, right? The blog is a great way, in my opinion, to start. And you also have the samples that Giedrius showed today linked into that blog. It's all like 3 sample code, it's 3 samples in one repo on GitHub, right? And it's that simple, right? There's not a lot of code going on there.
And it's 3 full stacks, so basically you do not have to do anything else. You just deploy using SAM deploy or deploy shell script, and you have that entire set of samples that I showed running in your account. There is no extra work added on your end, and you can use that as a starting point.
Yeah, I can probably even show it if we got 4
excellent.
minutes.
Yeah, no,
you want me to quickly show it?
No, go for it if you can. I can.
Okay. So
why not?
we're gonna do a quick marathon.
We always put Anton on the clock because he's. So what I did, I was just having that the streaming going on over here, because if you do implement this as well and you do something cool, I've got this sort of mental model of the matrix text because it's all in green, looking cool. So if you build something, let me know. Got to do some matrix kind of stuff as well. While Anton is bringing some, there we go.
Okay.
Yes.
So this is there are several ways to enable it, right? This is if you're using console, just pick buffered or streamed. If you're using Open API spec, this is the property response transfer mode stream, right? If you're using something like CloudFormation, again, response transfer mode stream, right? That's how you enable it. And from the code perspective, let me find a code snippet. Let's do Python, get it smaller. This is pretty much it, right? You just stream kind of chunks of your response back gradually one by one. This is what it looks like for Python. This is what it looks like for Node.js, right? You response stream.write, you wait, you response stream.write world, you wait, exclamation marks, and you end the response stream, right? So the usage is pretty simple.
Cool. In fact, that's a question. If you're using things like SAM local mode or things like that with API Gateway, Start API, or that kind of streaming, does that work if people want to test this out locally?
No, not that I know. And also testing an API Gateway console waits to accumulate. It doesn't show streaming response. It waits to accumulate enough data or timeout.
Cool, excellent, thanks. So yeah, if that's not working in the console, deploy the app and do the actual streaming via the command line, which
it supports streaming in the sense that
just
you can.
Got a minute left.
Yeah, it supports streaming. Testing in the console, it supports streaming backend integrations in the sense that it will not fail. It will just simply, in the user interface, it will accumulate data up to some amount of data and then show it as a chunk. And instead of showing that streaming matrix style, so maybe it's a question for Srijan when we will see matrix in API Gateway Management Console.
That heads into my next question. What's in the future?
Yeah, I think there are a bunch of items that we are thinking about.
What's the future of API Gateway? Anything people should be thinking? So what are your thoughts?
Yeah, I think there are a bunch of things that we are excited about. I think we're listening to all the signals from the field, Giedrius, Anton, your TAMs and all of them. Working through the prioritization process for this year, I think there are lots of exciting things there. So happy to talk about them on a future session, maybe.
Cool. Excellent. Well, thank you, all three of you. Awesome to catch up with API Gateway. We are basically doing all the new things that have come out. We've got a huge amount of chalk talks. These were the things that reInvent that you couldn't, that weren't recorded, that the breakout sessions that aren't on YouTube. So we'll be rolling. We've got a huge amount of them over the next few weeks. So it's really huge, a bunch of net new information to help you out. We'll be back same time, same place next week. Thank you, Srijan, Anton, and Giedrius. And thank you to super producer Jeffrey behind the scenes. See you next week. Bye-bye.